Today, scientists and engineers at IBM Research and Airlight Energy in Switzerland are announcing a revolutionary new solar technology which can concentrate the sun's radiation 2,000 times and convert 80% of it into useful energy to generate 12 kilowatts of electrical power and 20 kilowatts of heat on a sunny day, enough to power several average homes. Gianluca Ambrosetti, head of research at Airlight Energy, explains.
The system that we are developing jointly with IBM Research is a system that is quite different than other solar systems in the sense that it provides you more than one thing at the same time. On one side, it provides you electricity, and very efficiently so. On the other side, it provides you also heat, and heat at a quite high temperature, above 90 degrees C. And with that heat, we can do many interesting things by using cascaded processes.
The technology resembles a 10-metre high sunflower made of cement with a 40 square metre parabolic dish. The dish contains 36 elliptic mirrors made from thin recyclable foil with a silver coating, similar to the material used for potato chip bags.
The system is based on three main core innovations, three main components. One is concrete for the structure. So we use concrete instead of steel. These concrete components can be manufactured on site and have very interesting properties and also are inexpensive. On the other side, we have the use of pneumatic mirrors. So instead of having rigid glass mirrors that are normally expensive, we have mirrors made by thin metallized foils which are put into shape with pressure of the air. And finally, let's perhaps the most complex and advanced component is the receiver that is made of high efficiency photovoltaic cells that have been used by decades in satellites, and the very efficient cooling technology that IBM Research is developing and has developed over the past years also for the cooling of supercomputers.
The photovoltaic chips are mounted on microstructured layers that pipe treated water within fractions of millimeters of the chip to absorb the heat and draw it away 10 times more effectively than with passive air cooling. IBM scientist Bruno Michel explains.
So the solar receiver is several photovoltaic chips, triple junction photovoltaic chips that are mounted on a silicon cooler. And this silicon cooler has microchannels, and these microchannels take the heat with a very small gradient between the photovoltaic chip and the coolant. And we can make electrical energy available at high efficiency and heat at a fairly high temperature, which can find reuse in cooling, heating and desalination.
The concept is based on a similar technology IBM invented for cooling data centers and supercomputers.
The connection between supercomputing and solar technology is through the heat reuse. We noticed that data centers consume a lot of energy and all the energy is wasted. And we introduced liquid cooling, high performance liquid cooling with a very small gradient between the temperature of the processor and the coolant to make heat available for reuse. And we can apply the same technology also in the solar field.
With such a high concentration and based on its radical design, scientists believe that by 2017, with high volume production, they can achieve a base price which is 2 to 3 times lower than comparable systems. Scientists at Airlight Energy and IBM envision the solar technology providing sustainable energy to both urban and remote locations.
So the locations where this system is suited for are locations where, of course, you need both of the outputs of the system. So you don't need only electricity, you don't need only heat or what you can do with the heat, but you need both.
As part of an IBM Smarter Cities Challenge, municipalities can nominate themselves for one of the prototype systems. The winning locations will be announced at the end of 2015. Airlight Energy has spun off a new company called D-Solar to market, license and sell the system globally. This is Anne-Marie Cromack reporting.